Hello students, welcome to Shunya IAS. So today we are going to discuss an important topic for CSAT, and that is time and work. So now this is that kind of a topic which freaks students out. They are just confused what is going on here. But today in this discussion we are going to tell you a very simple, a very easy and the perfect way to solve such questions. Once you learn that is like the Brahmastra. You can just solve any time and work question with that approach that we are going to discuss today. So just pay attention here to what I am saying to you. So basically when we talk about time, when we talk about work, the basic idea we have is that suppose we have some work to do, and in order to complete that work we get some time, that in some time we have to complete this much of a work. Now some people are there who are really efficient, really productive, so they complete the work in a very small amount of time. Okay, so you call them more productive. So here one variable comes into picture, which is nothing but productivity. So basic concept which you are going to use in this particular topic would be time into productivity is equal to work. Okay, so what is productivity? The time taken by any person to complete a work. If a person is more productive, he will take less time. If a person is less productive, he will need more time to complete the same work. Let's say for example, we have a person and his name is A, and so we have to find the productivity of A. Suppose there is a work which has to be done. We'll call that work as small w, and in order to complete that work, that person take 5 days. So we can simply write 5 into A is equal to W. Time into productivity is nothing but work. So in this way, you can find actually the productivity of this person A as nothing but W upon 5. So W work will be done by him in 5 days, or you can say in 1 day he will complete 1/5 part of the work. Okay, that is simple way of saying that. So let us put that in a box and talk about some another example. Let the another example be like this, that some other guy is there and let us call him person B. The person B is not as efficient, and in order to complete the same work, he is actually taking how much time? He is taking 20 days. So you can see his productivity is much less. His productivity is going to be nothing but B is equal to W upon 20. So that W upon 20, which is the productivity of this person B, is nothing but the time taken to complete this work. So he will take 20 days to complete W work, or you can say that in 1 day he will complete only 1/20 part of that work. Okay, that is the basic idea of productivity, and this idea would be applicable throughout this particular topic. Okay, so now let's say some modification is provided to you. Now the thing is, both A and B are working together to get this work done W. So how will we write that case? So in that case, we will again have to write this particular equation. So suppose the case now is same work is to be done, W is there, but it is to be done by both of them together. So now A and B both are working, and how much time they will take, it is what we have to find. So suppose if we write the productivity of A as nothing but W/5, and the time he will take would be nothing but T. Similarly, if we talk about this person B, his productivity is nothing but W upon 20, and the time he is going to take is also T, because they are working together now. So they'll start together and they'll finish together. And now we have to find this value of T. What is this T equal to? So we can simply write one more equation. Let me just clear some space so that we can write down the productivity equation, and that productivity equation would be very simple. Just look at it. And so here we have time as T, which we have to find. Productivity, now both are working together, so the productivity will add up actually. So we will have A and B working together, so we have A plus B. The work remains the same, the work is only W. Now what we have to find? We have to find this value of T. In order to do that, we'll put the values of A and B from this part. We'll write T into A is nothing but W upon 5 plus B is nothing but W upon 20, is equal to W. What we'll do, we'll just add up both of these fractions. LCM is coming out here to be 20. Here you will get 4W. Here we will get a W is equal to W. Just write this part one more, and I'm writing it on the sidelines as a small equation now. So here we'll have 5W by 20 into T is equal to W. Now we have this very simple equation. As you can see, a lot of cancellations can be done. This W can be cancelled with this W. So we are now rid of this. 5 can be cancelled with 24 times, and ultimately you will get T by 4 is equal to 1, or simply you can say T is going to be how much? 4 days. So now if they are working together, the work can be completed only in 4 days. That is the basic idea of this particular question. Okay. So this was the basic concept, basic way in which we'll approach all these questions of time and work. And believe me, if you go through this method, there will be no such questions which you cannot solve, given that you practice enough with us. Okay. So going back, this is nothing but, the sneak peek of our course on time and work. So we have completed this topic exhaustively. We have covered all the possible questions which could be asked in the CSAT examination. So have a good look. And now we'll begin our discussion. Okay. So just read these questions properly and then we'll proceed. So here we have a person W who can do 25% of our work in 30 days. How can we write that productivity equation? So for W, that productivity is going to be W. How much time he is taking? He is taking 30 days of time. And how much work he is completing? He is completing 25% of the work. As we have seen before in percentage topic, this 25% can also be written as 0.25 W. Work is nothing but W. So we have this first equation. Now let us try to write the second equation about X. X can do 1/4 of the work in 10 days. So I can write W, sorry, not W, but X. X will take 10 days to complete how much? 1/4 of the work, or you can write it W by 4. Similarly, next you will have third person, that is Y, and he will do 40% of the work in 40 days. So we'll have Y into 40 is nothing but 0.4 into W. And finally the last part of it, and that would be Z can do it in 1/3 of the work in 13 days. So I can write Z into 13, the number of days, is nothing but W upon 3, the 1/3 work. Okay, so these are the 4 equations of time into productivity is equal to work I have written on the board for all these 4 people. And further, what is being asked? Further it is said that who will complete the work first? So who will complete the work first? The guy who is most productive. And now we have to compare all these productivities, this W, X, Y, Z, all these productivities we have to find in order to tell which person will do it fastest. So we'll just find out the productivities. For W, you can write it like this. W is nothing but, I am sending this 13 cross multiplication down here. 0.25, it is nothing but 25 upon 100. I am getting rid of the decimal into W. After all the cancellations, you will have W upon 120 as the value of this capital W. So I am just putting a bar on the top of it so that you do not confuse. So let me write capital W is nothing but small w upon 120. Okay. Now let's calculate the next one. The next one is going to be simple. X would be nothing but W upon 40. Just cross multiply. So we'll get X is equal to W upon 40. Next is Y. Y would be how much? 0.4 W by 40. You can get rid of this decimal, get a 10 here. Cancel it out, you will get the value of W upon 100. So you can write as Y is equal to W upon 100. And finally here about Z, you can just cross multiply it here. You can say Z is nothing but W upon 3 into 13, that is 39. So we have Z as nothing but W upon 39. So now we have found out the productivity of all these 4 people. Can you guess which of them is going to finish the work fastest? Please take a guess. And if you are not able to find the answer, it is very simple. See, here the productivities are given, which means W will complete the work in 120 days, X will complete the work in 40 days, Y will complete the work in 100 days, and Z will complete the work in 39 days only, which is by far the least amount of time. So Z is going to finish the work the fastest. So correct answer is going to be option number D, that is Z. Okay, so it was a pretty easy question, nothing difficult in it, not any laborious calculation. It was quite easy, and this is the kind of a question you can easily solve. These are the questions you should not miss in CSAT examination. Okay, moving on, we have one more similar question. So you can see the pattern of UPSC. Questions are almost repeated some of the times, sometimes even without changing the values also. So just have a look. So here we have X, who can complete 20% of the work in 8 days. So X in 8 days is completing 20% or 0.2 of the work. And another person, Y, is there, who can complete 25% of the same work in 6 days. So we can write Y in 6 days can complete 0.25 of the work. Now what we can do is just we can find out the individual productivities here. So X would be how much? X would be 2W by 10. I'm just getting rid of this decimal, into 8. After all cancellation, you will get W upon 40 as the productivity of X. Similarly, here you have Y, and here you can write Y is nothing but 25 upon 100 W into 6. Go 4 times, you will have W upon 24 here. Okay, so I have found out actually the productivity of X and productivity of Y. Now let us see what question says further. So the question says that if they work together, in how many days will 40% of the work be completed? So now we have to write the equation for third part also, and that would be how much? So if they work together, the net productivity would be X plus Y. How much time they will take, that we have to find. Let's call it time T. And then the work is how much? It is 40% of the work, that is 0.4 W. We have a simple third equation just in front of us. Now what we have to do, just look, we have to find the value of T. And how that can be done? By putting the value of X from here, by putting the value of Y from here. So we can write W upon 40 plus W upon 24 into T is equal to, I'll write it like this, 4W by 10. Okay. Now what we'll do, we'll just find the LCM, the fraction addition, nothing much difficult for you guys. So here the LCM will come out to be 120, 3W plus here we'll have 5W upon 120. Further you can write it like this, 8W upon 120 into capital T is going to be 4W by 10. What we can do, we can just cancel out a lot of values here. So here, as you can see, you can cancel out W, cancel out this 0, you can cancel out this and this here. Here you will get 2, cancel out this further, you will get a 6 here, and ultimately when you cross multiply, you will get the value of T as nothing but 6 days. And that is, my friends, going to be the final answer to this question, that is option number A. So here you can see it is a very similar question to what we see earlier. Okay, nothing difficult in it. So please do not miss such questions. And now you have the approach. As you can see, I'm using the same approach in all of the same questions. Okay. Now move on to the question number 3. That is, here we have Ram and Shyam with us. And now they are working together for 4 days to complete 60% of the work. So let's call Ram as R and Shyam as S. They are working together for 4 days and they are finishing 60%, that is 0.6 of the work. So this is going to be the equation. Productivity into time is equal to work. Now moving on, we have Ram takes a leave and then Shyam works for 8 more days to complete the job. So now this much part is done. Now Ram is leaving and Shyam is alone, and he's taking 8 more days to complete the job. So he's taking, suppose now Shyam is alone, he's taking how much time more? He's taking 8 days in order to complete the remaining work, and the remaining work would be how much? It would be nothing but W minus 0.6 W. Okay, so you can also write Shyam into 8 is going to be nothing but 0.4 W. Is this understood? Okay, so remaining work would be nothing but W minus 0.6 W, that is 0.4 W. Now, here what we have to do? We have to find in how long Ram will take to complete the entire job alone. So we have to find, actually the productivity of Ram, that in how much time alone he can do the complete work. If we get the productivity, that thing we can answer very easily. So the basic idea of the question is, you have to find this particular value, and in order to get this value, you must also know something about S. And how can we know something about X? By using this particular equation. So from this equation we can say S is nothing but, I am writing it like this, 4 upon 10 W into 8 goes in the denominator, will get cancelled, W by 20. So now we have the productivity of Shyam as W upon 20. What we'll do next? We'll put this value here in this part of the question. So just have a look. So now we are done with this. So I'm erasing it. And the thing which we need is nothing but S is equal to W upon 20. That is one thing we needed from that equation to actually proceed. So S is nothing but W upon 20. Now what we'll do, we'll just put the value of S here and get the value of R. So we have R plus W upon 20 is nothing but, I can write it like this, 6W upon 10, and this 4 will go in cross multiplication. So this way we have cancel out whatever we can. We will get 2, we will get 3. Overall we will get 3W upon 20. Or simply we can get R plus W upon 20 would be nothing but 3W upon 20. What we'll do, we'll just send this W in subtraction here. It will subtract, and ultimately we'll get the value of R as nothing but 2W by 20 minus W by 20. Sorry, 3W by 20. So we have this value further cancel out. You will get R as W upon 10. So what we have done now, we have actually got the productivity of Ram. So Ram's productivity is nothing but W by 10. And what we can get from this productivity value, we can get the inference that Ram can complete the work alone in 10 days, and that is being asked. So the correct option here would be option number C, that is 10 days is going to be the correct answer for this particular question. Moving on to the next question. A man completes 7/8 part of a job in 21 days. So this is first equation. So suppose we have to write the productivity equation. Since there is a man, I am writing M for him, and he is taking time as 21 days, and in this 21 days he will complete 7/8 portion of a work. Okay, so we have this first equation, quite simple. Further, how many more days will it take for him to finish the job if quantum of the work is further increased by 50%? Please try to understand what is going on. Please try to figure out. Just read this sentence once again with me. Follow. How many more days will it take to finish the job if quantum of the work is increased by 50%? So we'll go piece by piece. First of all, we have the information that quantum of the work is increased by 50%. That would mean if initially the work was how much? Work was W, as we wrote. Initially the work was W. Now you are increasing it by 50%. So 50% increase we are doing. How much will be the resultant work now? So we have done this. We have discussed this in percentage lecture, that if something is increasing by 50%, how will we write? 1 would be there originally. Then 50% can be written as 0.5. So we'll multiply the value with nothing but 1.5. So the new work would be 1.5 W. Okay. Are you getting the idea? The new work would be nothing but 1.5 W. Okay. Now it says how many more days will it require to finish. So how many more days is being asked. So one thing you must realize is that he has already finished 7/8 part of the work. Okay, this much part is already done. We are interested in the remaining work only. So how much will be the remaining work? Remaining work will be 1.5 W minus 7/8 W. Okay. So I'll repeat that again for you. Don't worry. I know that is something too much to bite at the same time. So how much will be the net work? Let me repeat it again. Number one, quantum of the work is increased by 50%. The new work will be 1.5 W. Secondly, how many more days will it require? That means this much of the work is done. How much time it will take to finish the remaining work? And this, my friends, is nothing but the remaining work. As you can see from here, this is the remaining work. And now what we have to find? The productivity would be the same because the same man is there. And we have to find the time. The further more days it will be requiring to complete the job. So what we have to do? We have to just simplify this particular equation. Okay. So now just focus on the calculation part of it because now that's left only. Here you can calculate the value of M. From here M would be nothing but 7W upon 8. I am sending this 21 in the cross multiplication down below. Just cancel out and you will get the value of M as nothing but W upon 24. Okay, we'll use this value here. So we have M as nothing but W upon 24 into T, which we have to find. This 1.5 W, it is nothing but 15 W by 10. I'm getting rid of the decimal. After further cancellation, you will get a 2 here, 3 here. It can also be written as 3W by 2. So I will write it like this: 3W by 2 minus 7W by 8. So the basic idea was to convert all of them in fractions. Since it is in decimal, it is in fraction. I am trying to convert all of them in a nice, beautiful fraction. So moving on with the calculation now. Here we'll take 8 as the LCM. We'll have 4. So we have 12W minus 7W. Here we'll have W upon 24 into T. You can further write this down again. W into T upon 24 is nothing but, here we have 5 W upon 8. Now we are ready to cancel out a lot of things. W can be cancelled. 8 and 24 can be cancelled. Just send this 3 in multiplication. You will get time is nothing but 5 into 3, that is 15 days. And that is going to be the final answer. That is option number D. So this question was also a pretty simple one. Here you had to take care of a few things like this. This is the most challenging aspect of this question. If you are good with this part, then each and every part except for this is a cakewalk for you. Okay, as I told you, and same thing I am repeating once again, the approach which I am using here is the same. There is nothing new which I am doing. So please just get a hold of the approach which I am telling you. So we have this one more question. Before moving on to this question, let me ask you a question that suppose there is a work to be done and you are hiring some people to do that work. Now there are 3 people. One is very efficient, one is kind of slow, and one is in between. He is neither too efficient nor too lax. So finally they have completed the work together and now you will have to pay. So how would you pay them? Would you pay them equally? Is there something like equality? No, you will not pay them equally. You will pay them in terms of their efficiency. The worker who is performing better, who is efficient, who is more productive, you will pay him a larger share. And that worker who is actually doing nothing much, he will get, somewhat less. I think the least amount he will get. And the worker in between who is neither very productive, neither too, slow, he will get something in between. So that is the way of dividing income. Okay, that is basic common sense which we have to understand. Now that basic idea is being used in this question also. So here we have P, Q and R. These 3 people are working together on a job. And so in what ratio should they share the earnings. So whatever the amount you are giving, in what ratio they will get this amount. So that ratio would be nothing but the ratio of productivities. We have actually to, in this question, we have to find the ratio of productivities. Okay, that is the basic mantra for this question. Now, just follow me up here. So P works thrice as fast as Q. P is working 3 times as fast as Q. We can write this in terms of productivity. One can say P is 3 times more productive than Q. That is the basic idea. The relation between efficiency is given. Second part of the question says P and Q together work 4 more times fast as R. So if P and Q are working together, net productivity would be P plus Q, and they actually work 4 times faster than R. So their productivity net is 4 times that of R, right? From here you can say that P is nothing but equal to 3Q. And if we put this value of P here, you will get 3Q plus Q is equal to 4R. Further you will get 4Q is equal to 4R. Cancel out the 4 on both sides, you will get Q is equal to R. Okay, so this is going to be the value. So now we have the value of P in terms of Q. Q is already in terms of Q, and then R is also in terms of Q. Now what we have to find is actually we have to find the ratio of their earnings, and the ratio of earnings, let me write it again for you that you can see black and bold. So ratio of earnings would be nothing but the ratio of productivities. So we have to find eventually what value? We have to find the value of P is to Q is to R. From this equation, you can see P is equal to 3Q, which I am going to write here. So here we have P as nothing but 3Q. Q you can simply write as Q, and from here you can say R is also equal to Q. So we have this part. If we cancel out Q from all the 3 sides, we will have the final ratio as nothing but 3 is to 1 is to 1, and that is the final answer. That is option number A. This question was, I would say a basic common sense based question, and you must know that all these concepts we have completed, we have exhaustively covered in our offline and online hybrid course, which I showed you earlier. So this is just a few questions. There are a lot in this particular topic, different varieties which you have covered, so nothing to worry about there. And so one related question also from such type of questions, time and work, is of pipes and cisterns. Okay, so like this work thing is there, that A and B are working, they are finishing the work in 20 days. You can see similar problems in which suppose there is a pipe P and it is filling a tank in, let's say, 15 minutes. Then there is a pipe Q, it is filling a tank in, let's say, 20 minutes. What can we do here? Suppose someone says both pipes are open, now in how much time they will fill up the tank? Such are the questions which are asked. They are basically the same as productivity. Let us imagine the same question as like this, that a person P completes a work W, the work W nothing but filling up the tank in 15 minutes. Similarly, a person Q completes a work in 20 minutes. In how much time they will complete the work together? So there is nothing different. The basic idea would remain the same. Now what we are doing, we are just replacing persons with pipes, and the time is same. The work is now filling up the tank. That is the basic idea. So here also, if one can say that concept is what? It is the pipe or the flow of pipe into the time it is taking is equal to work, which is nothing but filling up the tank. How it is different from, let's say, productivity into time is equal to doing the work. They are all the same things. Nothing is different. Just the face of it has changed. Nothing else have changed so far. Okay. So we'll proceed with one such question of pipes, and it is there. So I would want you to give it a good read. Okay, so now we'll look at this question. Two pipes A and B can independently fill a tank completely in 20 and 30 minutes respectively. Same thing is there. It is talking in terms of productivity here also. Let me write those equations first. So pipe A is taking 20 minutes to do the work. The work is nothing but filling up the tank. It is same. Now we'll write the second equation for B. Pipe B is taking 30 minutes to do the work, and that work is nothing but the same, W. We can also rewrite these equation as the flow of pipe A is nothing but W upon 20, and the flow of pipe B is nothing but W upon 30. It is nothing but the productivity, like earlier. Now the next part says, if both these pipes are opened simultaneously, in how much time they will take to fill the tank completely. So what is going on there now? Both A and B are now working together. We have to find the time in which they fill up the tank, and that work is represented as W. That is we have to do. Very simple calculation. Just put the value of A and B. So one can say W upon 20 plus W upon 30 into T is equal to W. Some LCM etc. I'm going to take here. So it will become 30. It would be nothing but 5W by 60. Further cancellation, you will get W upon 12. So this sum is nothing but W upon 12 into T is equal to W. As you can see, there is a lot of cancellation work. W will be cancelled and you will get finally T as nothing but 12 minutes. So pay attention, here we were talking in terms of minutes. So the final answer will also be in terms of minutes. And so correct option is option number B. So you guys see how easy a question it is. It is such an easy question, I tell you, that please do not miss such questions. These are the questions will make you, they'll take you to the safe zone. I just don't want you to be on the border of 33%. I want you guys to be much above it, in a safer zone. And so please do not falter in such easy questions, Now moving on to the last two questions of the day. And the last two questions of the day might seem like somewhat off topic, but they are not, because they are using the same idea which we have discussed here. And the idea which is we are talking about is inverse proportion. What is inverse proportion? Inverse proportion is when one thing decreases, another thing increases. Let's say we were talking about productivity into time is equal to work. If suppose work is constant, it is the same, it is not changing, then if you increase the productivity of a person, he will take less amount of time to do it. And on the other hand, if you decrease the productivity of a person, he will actually take more time to do it. That is the idea of inverse proportion. Same thing we were doing with pipes. So for pipes, let's say we write flow of pipe into the time taken, and the work is to fill the tank. Now we'll keep the amount of size of the tank as same, and if we increase the flow of pipe, it will take a lesser time to fill. On the other hand, if we actually decrease the flow capacity of pipe, it will take more time to fill the tank. These are the two basic concepts or equations which we used to solve all the previous questions. Now we have more different miscellaneous cases where the idea of inverse proportion is being used. So one such idea is what? Food. So suppose food is constant, there is fixed amount of food, and so the food can be written as number of people who are eating the food into time. So let's say there is a rescue operation going on, some disaster has hit, and people are being given food through rescue. Now if there are larger number of people and the food is same, it will last for less amount of time. But if same food is present, now in this case people are low in number, then the food might last for a longer duration. That is the case. So simple idea is, suppose you have a cook at your home who has actually prepared so much of food, and now if less number of people are there, suppose only 2 people are there to eat, it will take longer time to finish the food. On the contrary, if there are a lot of people, suppose there are 10 people now, they will take hardly any time to finish the food. That is the basic idea. So here the basic idea is, if you increase the number of people, the time for which food lasts will decrease, and similarly if you actually decrease the number of people, food will last for a longer duration. Same thing you can talk about fuel also. What is fuel? It is nothing but the food your vehicle consumes. There is not much of a difference. So fuel can be written as your consumption into number of days. Your time, we can also write it like that. So if you are consuming fuel in a larger amount, obviously it will last for a lesser amount of time. On the contrary, if you are saving fuel, if you are actually decreasing your consumption, the time for which fuel will last will increase. So these are miscellaneous ideas using the idea of inverse proportion. And now we are going to see 2 such questions. One of them would be based on fuel and another one would be based on food. Okay, so let's see. So here we have one question. It says the tank full petrol in Arun's motorcycle lasts for 10 days. If he starts using 25% more every day, in how many days will the tank full petrol last? So basic idea is, there is a person called Arun. He was consuming some petrol and it lasted for 10 days. Now he is increasing the consumption by 25%. So for how much time will the petrol last? That is the basic idea. So as I told you earlier, you can write about the first part, you can write fuel is there. How much is the consumption? Let us assume the consumption to be C. And for how much time the food is lasting? Fuel is lasting. It is lasting for 10 days. Okay, that is the first equation. Now we'll talk about the second part of the question. What he is saying, if he starts to use 25% more every day, so the consumption is now increasing by 25%. We'll just write it in this form. 1 plus 25%, that is nothing but 1.25. So the new consumption amount is going to be 1.25 C. This is the new consumption. The fuel you are filling up is the same, but now you have to find the time for which the fuel will last. So basically you have to find this value of T. Okay, is it clear so far? The basic idea of inverse proportion is being followed here also. Now what we'll do is just that we'll simply divide these equations, and here you can cancel out this fuel from this fuel, this C from this C, and ultimately you will get 1 is equal to 10 upon 1.25 T. If you send this T into cross multiplication on the other side, you will get T is nothing but 10 upon, here we have 1.25. Get rid of the decimal, you get 100. It cancels 4 times and 5 times, here you get 2. Ultimately you'll get the final answer is 8. And so if you increase the consumption by 25% more, the fuel will last for 8 days. So the final answer is going to be D, 8 days. So same question, very easy question, which it is such a question you should not miss in any case. Very easy calculation, nothing to do. But the idea is of inverse proportion. Okay, that you have to figure out. And so the last question of the day is here, in which we'll talk about one more concept of inverse proportion. Just have a look. So in a garrison, so what is garrison? Garrison is nothing but a military installment, military installation. So it is similar to a fort. And so there is a food for 1,000 soldiers for 1 month. So in a garrison there are, suppose many soldiers are staying, the food is for 1,000 soldiers for 1 month. 1 month is nothing but 30 days. That is the first case. Now what is happening? After 10 days, 100 more soldiers join in together to the garrison, how long will the soldiers be able to carry on with the remaining food? Okay, so now what is happening? There are, for 10 days there are 1000 soldiers. After 10 days, more 1000 soldiers are coming in. And now the question is, for how many remaining days the food will last? So we can write a very simple equation like this. And we can say that for 10 days, we had 1000 soldiers. After that, we will have 1000 and 1000, 2000 soldiers. And we have to find the remaining days for which the remaining food will last. So let's take the number of days as t. And the amount of food is same. It is nothing but food. Now what we have to do is that we have two equations now. Using the same thing, using first line I created this equation. Food into 1000 soldiers, food is equal to 1000 soldiers into 30 days. Second says, now initially there for 10 days 1000 soldiers are there, and for more t number of days there are 2000 soldiers overall, and the food remains the same. So in both of these equations you have food and food on both sides. What we can do, we can just put this value of food from here and put it here. So we can say it is nothing but 10 into 1000 plus this is nothing but 2000 into t, and food we can write as 1000 into 30. Okay, this is the overall equation. From this and this we are getting this final equation. What we have to do now is just cancel out the things. So what we can cancel out here, you can see easily, is that we can get rid of this 1000, this 2000 and this 1000. Ultimately we'll get 10 plus 2t is equal to 30. Send 10 on this side, you will get a 20. Finally you will get the value on solving this complete equation. You will get the value of t as nothing but 10 days. And so the remaining food will last for only 10 days. Why? Because the number of eaters have actually increased, and therefore the food will last for lesser number of days. So we have 10 days as the final answer. Okay, so the remaining food after the 10 days would last only for 10 more days. So overall one can say the food lasted for 20 days. Instead of 30 days, which was the original planning, it lasted only for 20 days overall, because the number of soldiers just increased. Okay, so that was the question, and I hope all your doubts, all your problems, all your concepts were clear with this discussion. And if there is further any problem, Shunya IAS is always there for your help. And so thank you so much.